Hello everyone, welcome back to my YouTube channel. Myself Sneha Jagdish Pudiyal. I am studying in Sri Venkateshwar College of Engineering, Department of Electronics and Communication Engineering. And the lesson is 1BE23EC108 and subject is mathematics, and let us discuss about the topic is convolution theorem. Introduction to convolution theorem. The convolution theorem is a fundamental concept in a signal processing and mathematics. It describes the relationship between the Fourier transfer of the two functions that are convolved in the time domain. The theorem states that convolution in the time domain is equivalent to the multiplication in the frequency domain. The convolution theorem is a fundamental concept in a signal processing and mathematics. It relates to the operation of convolution, which combines the two functions to produce a third function. The theorem states that the convolution of the two functions in the time domain is equivalent to the multiplication of their Fourier transform in the frequency domain. And the time domain convolution. In the time domain convolution is an operation that combines the two functions to produce the third function. It is commonly used in the signal processing to model systems with the linear time, invariant and the characteristics. The convolution of the two functions f of t and g of t is denoted by the f. Understanding the convolution. Convolution is the mathematical operation that expresses the way of one of the function modifies another. It involves the liking one function and shifting it and multiplying it with the another function. Convolution is commonly used in signal processing and image processing and other areas of mathematics and engineering. Frequency domain convolution. The Fourier transfer of a convolution of two functions is equal to the pointwise product of their Fourier transfer. Mathematically, if f of w and g of w are the Fourier transform of f of t and g of t respectively, then the Fourier transfer of their convolution is given by f of w and g of w. Importance to convolution theorem in a signal processing. And what is the importance? And in signal processing, the convolution theorem is used to analyze the manipulate signals, and second one is it enables the easier filtering and the modulation and analysis of signals in the frequency domain. And third one is the theorem helps in understanding how signals interact and change over time. Then applications in image processing. And what are the applications? And first application is in image processing. The convolution theorem is used in techniques and such as image filtering and edge detection. And second point is applying the convolution in the spatial domain can be computationally expensive, so transferring the image to the frequency domain can speed up the processing. And third one is by convolving the image with the kernel in the frequency domain and desired effects can be achieved efficiently. Then application of convolution theorem. Then first one application is the convolution theorem is widely used in the image processing for a task like a blurring and the sharpening and the edge detection. It is also essential in a communication system for filtering and modulation of the signals. In a mathematics, the theorem has applications in solving the differential equations and analyzing the systems. Relationship to describe the Fourier transform. The convolution theorem also holds for the discrete signals and their discrete Fourier transforms. When dealing with the discrete signals and the convolution in the time domain corresponding to the element wise and multiplication in the frequency domain. This property is crucial in digital signals and processing the applications. Advantages of using the convolution theorem. Then first advantage is the convolution theorem simplifies the complex calculation by transferring the convolution operations into simple multiplications. It provides an insight into the frequency contents of the signals and images. The theorem improves the efficiency and accuracy of the signal processing and algorithms. Convolution theorem in a communication theorem. That is, first one is in a communication system, the convolution theorem is used to analyze the effects of the transmission and channels on the signals. By understanding the frequency response of a channel, and engineers can design the efficient modulations and coding the shims. The theorem allows for the manipulation of the signals in the frequency and domain to optimize the communication performance. Convolution theorem in audio processing. In audio processing, the convolution theorem is utilized for a task like adding the reverberation or applying the filters to audio signals. By convoluting an audio signals with an impulse response in the frequency domain, and a realistic effects can be achieved. This technique is commonly used in audio production and the sound engineering. Relations to Laplace transform. The convolution theorem has an analogous form in the Laplace domain known as the convolution integral theorem. This theorem states that the Laplace transform of a convolution two functions is equal to the product of their individual and the Laplace transforms. It is a powerful tool in analyzing the linear time invariant systems and the differential equations. Limitation and consideration. While the convolution theorem is a powerful tool and it is important to consider the assumption and the limitation of its applications. Nonlinear systems and the time-varying systems may not adhere to the theorem's principles, and care must be taken when applying the theorem to ensure the validity of the results. The convolution theorem assumes that the functions involved are the integrable and the well-behaved. It may not be directly applicable in a cases where the functions do not meet the required conditions. In a partially applications, care must be taken to ensure the validity of the theorem assumptions. Then future development in a convolution theorem, and what are the developments? The first development is research is ongoing to expand the applicability of the convolution theorem to more complex and systems. Advances in computational techniques and the algorithms are enhancing the efficiency of the convolution-based operations. The theorem continues to be key the tool in signal processing and image analysis and other fields. Conclusion. And what is the conclusion convolution theorem? The convolution theorem is a powerful concept that connects the time and frequency domain in a signal processing, and it simplifies the complex operations and provides the valuable insights into the behavior of the signals and systems. And third one is understanding and applying the convolution theorem can lead to more efficient and accurate analysis in a various fields. And fourth one is the convolution theorem is the cornerstone of the signal processing, providing a powerful link between the time and frequency domains. Its applications span various fields from image processing to communication, systems and audio engineering. And last one is understanding and the leveraging in the convolution theorem can lead to efficient and effective solutions in a signal processing task. Thank you for watching the video. Please like the video.